Okay. How was the exam? Very tricky. We had 7 A's, 4 straight A's, 3 is A minus, and then we have we don't have a B plus. We have a B 5, B minus 4, C plus 2, C 2, C minus 2, D plus 2, fail 1. So fail is, I think it's below 59. So if you get below 59, you fail. So if you have any issue with the grading, you can let me know, and then we'll check. Okay. All right. Any question up to this far? You have an issue with your homeworks? All right. So since we don't have any question, let's start a new chapter. That is chapter 6.1. You have your notes in the movie, so you can check your notes in the movie. So I will put a solution manual by tomorrow. Okay. So you'll get a solution manuals. You check where you went wrong, and then you can ask me any question about it. Okay. All right. So today we're going to look at section 6.1. 6.1. The greatest common factor. Greatest common factor. So the greatest common factor of 2 or more expressions is the largest expression that is a factor of all the expressions. So the greatest common factor, GCF, of 2 or more expressions is the largest expression that is a factor of all the expressions. So here you need to factorize the expressions, and then you get the greatest common factor there. So there is another one called the least common factor, which is the smallest common divisor. Call it maybe divisor. But here we're going to discuss the greatest common factor. So how do we get the greatest common factor of like 2 expressions? So number one, you factorize each coefficient into primes. So first, start by factorizing each coefficient into primes. So you factorize the expressions into primes, and then you write all the variables with exponents in expanded form. So you write all the variables there in the exponent in the expanded form. Number 2, list all the factors. So you list all factors. You list all the factors. Number 3, bring down the common factor that all expressions share. So you bring down the factor that the expression share, the common factor that the expression share. And then number last, multiply the factors. So bring down common factors that all expressions share. And then number 4, and then multiply the factors. So you multiply the factors. So we are going to look at several examples on how we're going to solve this. So number 1, factorize, find the GCF of 45 a squared b cubed and 18 a raised to 4 b. 18 raised to 4 b. So using the 4 steps that we've done over there, so we can start. So you can write, I have 2 ways of doing this. So the one we're going to use the one in your textbook, and then maybe I can show you the one which I usually use. So you write like this. So you start by putting in this form. So let's put it like this. 5a squared b cubed, and then down here we put 8a raised to 4 b there. So you can put it like that. So the first step was factor each coefficient into primes. So you look for the prime of the coefficient. So the coefficient is this 45 and then 18 there. So you factorize the coefficients into primes. So you can put it like that. So the first one, you look for the smallest, you start by factorizing from the smallest. So what is the smallest factor that can divide 45 and 18?
3.
So we start from what? 3 there. Also 18 is what? 3. The next one which can divide 45 is what? This next smaller one which can divide 45 is what? So what is remaining after you divide 45 by 3?
15.
So 45 divided by 3 is what?
15.
So let me show you how you can look for the factors, let's say of 45. So you start from that way. So the smallest here is what? 3, right? So when you divide 3 by 45, you get what? 15. The next one is what? 3, and then you get what? 5, okay? Then for 18, we have what? 3, and then we have, what is 18 divided by 3?
6.
So first of all, the smallest for this case is what? 2. So when you divide by 2, you get 9. Then you come to 3, you get what? 3. So here the first one is 3, which is this. And then the next one is 3 there, and then 5 there. Then for 18, we have 2. Then we have 3 there. And then we also have 3 there. Okay. So when we come to, then we now factorize the other ones. So the other ones are, we have A's, so we have the A here, and then we have another A, and then we also have another A, and then we have 3 B's there. B, B, there. So for 18, we have 4 A's, so A, 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 and then we have B. So we can arrange this one in a form where we can get a common factor. So we've already gotten factors there. So we write in this form now. So 45 A square B cube, and then we have 18 A raised to 4 B there. So the smallest common factor, the least common factor there, which can divide, the least which can divide 18, there is 2, but we don't have the one for what? 2 doesn't divide what?
45.
45. So the next one there is 3. It divides 18 and also divides 45 there. And then we also have 3 again here. It divides 45 also, and also divides what? Yeah. And then the next one is what? So we have we have 5, right? So 5 there divides what? 15, but it doesn't divide what? 3, 18, sorry. So the next one is what? So the next one we have the A's now. So how many A's are there? A in 18 is A, and then another A there. And then for this one we have 4 what? 4 A's. So we have A there. We don't have the S there, and then we have the B, 3 B's there. So we have, for this one, we only have 1. So what is common there in both of them? So the common here is 3, okay? We have another common here, which is 3. We have another common here, which is A, another common A, and then the last one, B. So we now multiply the common factors there. So now we have 3 times 3 times A times A times B. So finally, what we get here is the greatest common factor here will be 9A square B. 9A square. Are we together? Is that clear? So I have another way of doing this. I usually put it like this. 45 A square B cubed, and then 18 A raised to 4 B. Then I start putting like that. I don't know whether you were doing like this. So I start by putting here. So when I put here, so I start by putting the common one, which can divide the common one there, which can divide both of them, which is what? 3. So 3, when you divide 45 by 3, you get what? Get 15. And then we have A square B cube. And then we have here what? 6 what? 6 A raised to 4 B. Then I put the next one, which is 3 also. So when I put 3 there, we get 5 A square B cube. Then we have here 2 A raised to 4 B. Then another common one which can divide there is a square. So a square there. So we have 5b cubed, and then here what is remaining is 2a square b. Then lastly, we put here b. Then we have b 5b square, and then we have 2a square. And then there is no other common one there. So I multiply the three of them here. But I think the first one is more effective and it will reduce some errors. So you reduce errors if you use the first one. So example number 2. Find the GCF of 108d square and 216d. 108d square and 216d. So what you do, you factorize first the coefficients. So we have 108, and then so we start from what? Looking for the smallest, the least common factor there. So we have 2. When you divide 118 by 2, you get what? 50 what? 54. Then we have 2 there. You get what? Is it 27? Then we have 3. You get what? 9. And then we have 3 and 3 there. 216. We start from, if you divide by 2, what do you get?
108.
1 or what? 108. Is it 108? Yes. So, and then 2, you get 54. And then you get, if you divide by 2 again, you get 27. So when you come to 3, you get 9 and 3 there. So those are the facts, the prime factors of 108 and 216. Then using the same method that we did, then you come here and now draw 108. So we can put the d square and then 216 d. So the first one there is 2. So we have 2 for 8. We also have 2 for 216. So you also have 2 there. The next one is 2 again. 2 there and 2. The next one is 2 for 216, but we don't have another 2 for 108. So we have 2 for 216 there, and we don't have anything there. Then the next one is, so we're done with that. The next one is 3 for both of them. So 3 and 3. The next one is, so that one is 3 is gone. We have another 3. And then lastly, we have the last 3 there. We have the last 3 there. Then we now get the D's. We have 3D, 2Ds for 108, and then we have only 1D for 216. So what are the common factors there? So first we have the 2 here. We also have the 2. We don't have anything here. We have the 3 here, the 3, and the 3, and then lastly we have the D there. So what is the greatest common factor? So we have multiply here. So it will be 2 times 2 times 3 times 3 times 3. So what is our greatest common factor then? So 2 times 2 is 4. 3 times 3 is 9 times 3 there. And then times D. Are we getting 108? D. So our greatest common factor there is 108. Is that clear? Any question? Okay, you can try this. Find the greatest common factor of 21 m raised to 5 n raised to 2 and 28 m raised to 4 n raised to 2. What is the greatest common factor of that? So first you look for the what? Look for the, you factorize 21, get the least common factors there. So the least there is what? What is the least number that can divide 21? 3 for what? 7. So we only have 2. So for 28 we have what? 2 for what? 14, right? And then we have 2 there for 7. So we have 3, 7, 2, 2, and 7 there. So using the same way, so you come here, you now get 21 m raised to 5, n raised to 2, and then we have 28 m raised to 4, n raised to 2. So we start from what? The least one there is what? 2 here. For what? For 28. Okay? So we don't have 2 for 21. So we also have another 2 for 28. We don't have 2 for 21. Then the next one there is 3. Do you have 3 for 21? We don't have 3, right? Sorry, we don't have 3 for 28. So we only have 3 for 21. And then we have the 7 in both of them. Okay? And then now we factorize the other ones. So how many hems? M are 5. So 1, 2, 3, 4, 5. And then we have 2 N's there. So for the 28, we have 4 M. So M, 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 M. We don't have 1 M. And then we have 2 N's. So N, and then M. So 2 is not common to both. 2 is not common here again. 3 is not common here. We have the 7 there. Then M is common here. We have M, M, M. We don't have another M there, which is common. And then we have N, and then N there. So the greatest common factor there will now be 7. And then we have 4 M's, and then 2 N's. So finally, what we get is 7 M raised to 4, then N raised to 2. So there we have the greatest common factor. Are we together? Is that clear? Okay, now if you're given 4 of them, 3 expressions like this. 12 z raised to 3, 45 z raised to 2, and then 18 z raised to 5. Find the common factor. Find the common factor. So you do it the same way. So you do it using the same way. First, you look for the common factors for the prime factors for the coefficients. So we have 12 there. So for 12, we have 2. 2 divides 12, you get 6. We have 2 there, then 3. For 45, we have 3 there. For 15, and then 3, 4, 5. Then for 18, we have 2 for 9, and then 3 there. So using the same way we've done, then we put it in this form, 0 raised to 3, and then 45 z raised to 2, then 18 z raised to 5. And you divide like that. So the first one there is 2. So 2, so we have 2 for 12, we don't have 2 for 45, and then we have 2 for 18. Next one is 3. So we have, no, the next one is 2 again. So we have 2 for 12 again. So we have 2 for 12. We don't have another 2 here for both of 45 and 18. Then we come to the next one, which is 3 for all of them. So we have 3 for 12 there, 3 for 45, and then 3 for 18, 3, and then 3 there. And then lastly, we have another 3 for 45, and 3 for 18. So 3 for 45 and then 3 for 18. We don't have another 3 for 12. Then we have, so 3 and that 3 there. Then finally, we have only 5 for 45. We don't have 5 for the rest. Then now the z is there. So 3 for 12. So z, z, z. Then 2 for 45. And then 5 for 18. So then come this way. So what is common? So common one is 3 there. And then what is common again here? Z, Z there. So what is the common, greatest common factor there? So we have 3 times what? Z times Z. So we have 3 Z squared. So we have 3 Z squared.
So is the 5 not included?
So 5 is not common in 3 of them, okay? It's only dividing 45. Yeah, so we look for the common factor, which is dividing all of them there. So the one which is dividing, so this is all, 2 is only dividing 2 and 41, 18, 2 for this one. 3 is now dividing all of them, okay? And then 3 here only for the 2 of them. And then 5 is only for 45. And then Z, the 2 Z's here will divide all of it. Is that clear?
Mhm.
Yeah. So the greatest common factor there is 3Z squared. Okay? Is that clear? Right. So we can use this way in now grouping an expression. You can be given an expression and then you're told to group it into a certain form. For example, factorize q squared minus 2q plus 6q minus 12 by grouping. So you're given something like this, and then you're told to factorize that one by grouping. So how will you group that? How will you group it? So here, as you can see, in all these equations, in all these expressions, we don't have a common factor. But we can get a common factor by grouping them. So you can get a common factor here, then you can also get a common factor there. If you group the two, the expression there. So the common factor here, the greatest common factor here is what? So we can divide both of them. What is the greatest common factor? Q, right? So Q can divide both of them there. So when you put out Q, then what will remain there? So what will remain when you divide this one by Q? Q. And then again, what will remain Yeah, when you divide by Q. 2. So Q minus 2. Plus, so you take this. Then, what is the greatest common factor in 6Q and 12? What is the greatest common factor? 6. So 6 can divide both, right? So plus 6. So you put it 6 there. So again, make sure you consider the signs. Here, this one is positive. So make sure when you open that bracket, then if it was negative here, then we need to change this sign. But now, if it is positive, then when you multiply, when you take this factor here inside, because it's a positive, then it will not change because, yeah, okay? So if it was negative, then we need to change this, but now it's positive. So the common factor there is 6. So when you divide by 6 there, what is remaining? Q, right? And then minus what? What is remaining here? 2. So we form an expression like this. Now, we can still write this one in another form. So how can we write this? What is common again here? The common one is what? Q minus what? Then we factor it out. So when you factor this one and this one out, then Q minus 2, when it comes out, then what will remain? Q plus 6. So that is how we factorize it by grouping. Is that clear? Okay, let's do another example. Factor x squared minus 6x plus 3x minus 18. So we can do that one in the same way like what we've done in the previous one. So by grouping, so you can group this because you can see the common factor there, and then you can also see the common factor in 3x minus 18. So what is the common factor, the greatest common factor in x squared and 6x? So the greatest common factor there is what? X, right? So when you factor out x, then when you multiply this x, when you divide this one, what you do get? You get x, then minus what? Minus 6. X minus 6. So again, we have this sign. So you bring it down here, plus. So what is common between 3x and 18? So we have 3. Again, make sure you look at the sign there. So when you factor out 3, then what will remain? So we have x minus what? Minus 6 there. So what is the common factor, the greatest common factor, again here? X minus 6. So x minus 6, then x plus what? X plus 3. Okay, so I have another one here. Another example. (25m raised to 5 minus 45m raised to 3n minus 45m n raised to 7. Factor that. Factor the expression. Factor the expression. So here we cannot group this because we only have three expressions, three of them. So what we do, we use the first way we did. Like now we are grouping this, we now look for the factors for this. So we start by looking for the greatest common factor in each one of them, and then we factor it out. Okay? So here we start by looking for the greatest common factor. Let's say we factorize 25. So when we factorize 25, is 5 for 5 there. When we factorize 45, then we have 3, then 15, and then 3, and then 5. And then when we factorize again 45, then we have 3, 3, and 15, and then 3, and then 5 there. So using the same way we did for the other one, so 25m raised to 5. So we look for the greatest common factor in each one of them, 45 m3n, and then 45 mn raised to 7. So let's look for the greatest common factor in the three expressions there. So the least one there is 3. So no, 3 is not dividing 25. So we have 3 and 3 there. So that one is 3 and 3. We also have 3 and 3. 3 is not for 25. Then we have 5, 5, and then 5 there. Okay. We also have 5 for 25. So 5 for 25 there. So we don't have 5, another 5 for the other ones. Then we have how many m's for 25? So 5 m's. Then we have 7 n's. So we have 7, no n for 25. So we have how many m's for 45? 3 m's. And then we have only m for that. So we don't have n for 25. So we have n here. And then we have 7 n's. And the 7 n's there. So what is common there? So the greatest common factor there is 5 here, and then m there. So we have 5 and then m over there. So you factor it out. So when you factor that 5m out, then what will you remain with? So when you divide 25 by 5, you get what?
5.
5 what?
M.
M, this one is m raised to 4. So you reduce this power by what?
1.
By 1. So it will be m raised to 4 there. And then that side will remain. So when you divide 5 by 45, you get what? 9. M will reduce by 1, m square. N will not reduce, So it will remain, and then minus 9 what? 9 m will go because this one we factor it out, and then what will remain is n raised to 7. So that is how we can factorize an expression. So because of time, you can go check the other examples which are in your notes. Then we can meet on Wednesday.
I'm gonna send you an email later. I have to run my other class. So
Oh, you're doing another
I was just gonna, yeah, I'm gonna send you an email later about my test if that's okay.
Okay.
Thank you.
Did you, anyone who did not get your
Price. Thank you. Am I gonna have to take it online?
So you will, there is another lady who did not do the exam. So she's going to do it at 1. Are you available at 1?
I have a team meeting at 1.
What time are you available?
Tomorrow I'm available.
About at around 3.
3?
Yeah.
I don't know about. Could you do? Is there any time earlier than 3?
Yeah,
tomorrow?
I just want you to do it for 1 hour, 30 minutes.
I could come in like.
You
In
will
the
do it
morning?
at home, and then you will send it to me. So I'll give you the time when you, just give me the time when you will be ready so that I can send it, and then I give you 1 hour, 30 minutes, you do it, and then you send it back.
I need it. Yeah, I just need to check my schedule tomorrow.
Okay. How about today?
Yeah, I won't be able to take it today. Cause
So tomorrow, what time?
Why don't you make it a time test?
Hmm?
Why don't you just make it a time test? So like as soon as he starts it,
Yeah,
he has
that's what I
to
want
finish
to
in
do.
an hour. So that it's like some of my teachers doing it where they open it at that time and then they close it at a certain time. But if you just have it where it's set up to start and then close,
Yeah, that's what I want to do.
yeah, I'm trying to.
so he has the choice between what time he wants to do it. But
I-
once he starts, he has to finish it.
I could
Yeah.
take it at 8 tomorrow.
Are you also available tonight? Maybe you can do it at night.
Yeah, I could do it tonight.
Or tonight?
You
At
like
around,
6 or 7?
I have a class at 7 to 8. Can we do it at, can you do it from 9 p.m.?
Yeah.
Okay.
9?
All right.
Okay.
Right. I had difficulties with the word problems. And like I realized the only reason I had problems was because I was adding when I was supposed to be subtracting on one of the crucial parts.
Yeah, I saw it.
And I was like, oh.
So if you make such an error, man,
So then like on Newton, I spent like 9 hours trying to get the word problem assignment done to the point where I was like, I'm done. And then like I went back to review for the
I
test.
don't like water problems as well. They're so
Oh.
frustrating.
Yeah, I went back to review on the before I started the test, and I was like, really?
You did something. Yeah.
9 hours
But you
of
did
work?
well. I think you're the leading one.
Yeah, I got a
class.
98.
Yeah, you did well.
I figured it out like right before the
It's
test.
only one which you missed the sign, right? I think it's only one.
Yeah, it's
question.
fine.
Yeah.
Yeah, I
Like
messed up
what I
there.
told you, if you miss a sign, then I'll reduce 1 point.
Yeah, which is
So that
okay.
people will reduce making some
Yeah,
mistakes.
some of my math teachers I had before, it was like, you messed up the sign. Oh, it's all wrong. Have a great day. And I'm like,
All right. See,
see,
do you have any other issue?
oh no, I was just like, that's why Newton, the homework assignment hasn't been done. Because I spent like 9 hours trying to figure it out.
Mhm.
And then it was like, what is it into the test? Where I was like, oh yeah, we could write on paper to write a notebook. So then I started making that.
Mhm.
And then I was like, oh, there's a
I think
problem.
two of the questions there were in the homework. I think
Yeah.
some of the questions there were in the
Yeah, I
homework.
just didn't do the Newton.
Yeah.
It was just because I couldn't figure out that one little step.
There was the last question which I thought I made a mistake, but finally I realized, oh, it was correct.
Okay.
All right.
Well,
See
have a
you.
good day.
You too.